Hi, in this video we're going to be trying to fix up this little Anbernic RG35XX, and it's brand new but faulty. In the listing it said that it doesn't charge, so I paid £23 for it. I don't know how you switch it on. Has it got an on-off button somewhere? Here we go. And it shows up with the battery indicator there, upside down. So let's take it apart and see if we can figure out what's wrong with it and if we can repair it. I think what I'll do first, I'll get my little USB tester, we'll plug that in and we'll see if it's drawing any current first. One moment please, I'll just grab that. So we'll plug this in. And I'll just zoom down a bit so you can see. And it's not drawing any current. I'll just plug that in again. So it is indeed not charging. Right, let's see how it comes apart. Looks like we've got some little Torx screws around the outside there. So let's remove those. I'll just get this packaging out of the way as well. And it appears to be a Torx T6, I think it is. Right, that's all of the screws removed. These ones are just holding on. Right, let's see how it comes apart then. Let's see if I've got one of these little plastic smudging tools. I don't think I've missed any screws or anything. It must just be clipped. I can see some clips along the sides here, so let's leave that one in there and I'll just grab another one. Right, we're making progress now. Right, so just get these little switches out of the way just so I don't lose them. So there's the battery. Let's just zoom down a bit and let's see if I can see anything on the board. And I can't see anything up to now. So this is where the power comes in on the USB socket. Looks like we've got some little power supply type chip there with 4 inductors, so I presume it must generate 4 different voltages out of this. Looks like possibly some small resistor there. That's probably an audio amp because it's next to the speaker. So I'm wondering if the charge IC is on the other side of the board from here. But I can't see any blown components or anything up to now. So I think the next thing to do is remove this screen. We'll remove these screws and see if we can get this board out of its case. Right, I'll just zoom out slightly. I'm just going to disconnect the battery for the moment. Now what we'll do, we'll just check to see how much voltage is in this battery. Just in case it's a problem with the actual battery itself. I'm sure they said that they changed or tried a different battery. I'm just going to voltage DC and I'll just zoom out a bit to get the meter in shot. We've got 3.5 volts in the battery. So, not the battery. Right. That's good because it's probably more interesting now. Let's just move these out of the way and we'll zoom down and see if we can get this board out. So it looks like we've got a screw here, a couple of screws there, screw here and a couple of screws there. Right, let's get those out. And I'm just going to open the display connector here just to remove the display. Right, I'm just going to get a plastic tool to do that. Right, let's see if this board wants to come out now. I'll plug this little speaker here as well. Let's use my tweezers to do that. Right, that's the board out. Let's just zoom down on that, and I can't see anything on this side either. Can't see any charge control chip or anything. I would have thought there would be some kind of charge control chip on here, but there's very little on this side of the board. Just got a couple of little transistors and a little diode there by the look of it. Right, I think I'm going to bring the microscope in just so I can have a look over this board with the microscope, because I can't really zoom down anymore with the camera, so I'll get the microscope set up. So this is the TOMLOV 4K-AF Max microscope that I'm using, and it's got autofocus, so if you want to, let's say, focus on that, you just hit a button and there you go, it's all focused in, which is pretty useful. It's actually not a bad little microscope. So we'll switch over to the microscope view and we'll have a look over this board to see if we can see anything that's blown. So where does the battery connect? So the battery connects here. So it looks like the positive comes up here, disappears under there, and then possibly goes to this diode. So I wonder if that's the charge IC here. I'll have to look up that one. So it looks like QWFYB. I've got another little chip here. I don't know whether that's anything to do with the charging or not. And this chip looks like the main power supply there. So it's an AT-02603C, I think that is, or was it G? Looks like we've got a current sense resistor here. So what's that? 0.02 ohms. Let's just go on to ohms and let's just see if that's intact. And yes, it is. Let's just check this diode. So I'm just going to diode check. And that's okay. All of the pins on the USB-C look okay. I think there are more pins under this, but we can't see them. I'll just see if we can get a shot of the inside of the USB connector. I'll just have to raise the microscope up a little bit. No, is that corrosion or something in there? Let's see if I can focus that in anymore. I don't know what there is in there. Has it got damaged pins in there? It's a bit hard to see. Let's just have a look at the other side. I've not really looked at USB-C ports much, so I'm not sure what it's supposed to look like. It just doesn't look quite right to me, that. Let's plug some voltage into it and we'll see if we get any voltages on any of these pins here. Right, I'll just go and hook up a little USB power supply. Right, let's plug this in. Let's just see if we get any voltages coming in on this. So let's just try that pin. Yes, we're getting 5 volts there. Does it come into here? So we've got 3 volts there. So we've definitely got voltage coming in. So I'm just wondering if this is the charge IC. I'm just going to unplug this a sec. Let's just see if that output there goes to here. So I'm just going to go on to continuity. Let's just go on this point here. Let's see if it goes to here. No. Right, so it looks like the battery goes to this point here. So I wonder if it's this IC that's faulty. Well, then again, that would be... Yeah, I'm just trying to get my head around this at the moment. So I think what happens is, as the battery's powering the device, it will go through this current sense resistor to this IC here. That makes sense, but not necessarily the charging of it. I'm just going to look up this IC here, see if I can find out what that is. Well, I've been having a look around the internet to try and find some information on this chip here, and I think it might be an SY6280A, because that begins with QW, and I think the rest's either like a date code or something. So I think that's what that chip must be. But it seems that the battery charging is actually done with this IC here. And I managed to find the data sheet for that. And I think these pins here, one controls a MOSFET for the wall input, is what it's called. And another line here controls another FET or MOSFET for the battery. And I think this pin here might have been the main power in. I'll just bring up the data sheet so we can have a look at that. Yeah, so the wall input is this one here. So this is where the 5 volts comes in from the wall input, from the USB. But that gets switched by a MOSFET, which is controlled by this pin here. And there are two MOSFETs here. So let's see where this pin goes to. I'll just put the meter on continuity. So, we'll go from here. Let's see. Let's check my probes there. This one. So this FET here controls the wall input. So I guess the output and goes to there. So this must be the input here. It's also connected to this MOSFET here. So what's that one? Let's see if that one's battery enable. Which it is. So why is that going to the wall thing then? Let's see where this pin goes. So the battery goes to there and switches it to this pin. Let's plug it back in. Let's see if we get any voltages on any of these MOSFETs. Let's go into volts DC and let's see if we get any voltage. So we're only getting about 0.2 on here. We should have 5 volts, so I'm only getting 0.2. Let's have a look what we get on here, because there's a 5 volt going into this. Well, I've got 4.6 there. Now it goes through a diode, so hold on. Got 5 volts there. 5 volts there. 4.9. And then we've got 0.2 on this one here, which is the same as what we've got over here. Interesting. So I wonder if there's something wrong with this here. This is supposed to be a current limited P-channel MOSFET if it's the right chip. So I wonder if those two, actually there's an enable pin. Which is this pin here, I think. And there's another one for setting the current. I don't have really anything on those pins. And then again, how would it be enabled? Let's see if I can trace through where that goes. So that seems to disappear through this side of the board. Let's just flip this board over a second. So I guess that comes in, is it maybe here? And it seems to disappear off up that way. But I think that's where our two MOSFETs are, round about here. So if we're a diode here going to that trace, which then goes to here. I'm just looking at that resistor there and just see there's a line or something or a scratch on it. Let's just zoom down a bit. Or is that a brake? It's hard to tell if that's just a scratch or a brake, because it looks like it's... Could just be a scratch. It looks a bit discoloured, that resistor. I'm just going to get some isopropyl alcohol, but just try giving that a bit of a clean. Let's try giving it a clean with a bit of cotton bud, see if we can... Still can't tell if that's a scratch or a brake. I think that may be cracked, you know. I'm just going to try and see if I can just clean this off a little bit more. Yeah, definitely seem to have a bit of a lip there. I wonder if I heat it up with a soldering iron if it'll just drop apart. Yeah, I'll just see if I can measure any resistance on it first, just before I do that. So about 437K. It could just be a coating on it. It just looks a bit weird. In fact, is there even a resistor there? Or am I just down to the pads? I don't think there's a resistor there. I think it's just down to the pads there. I'm just going to add a little bit fresh solder to that. Yeah, I don't think there's a resistor there. I wonder if I was just measuring something else in circuit. Let's just try that. So is there supposed to be a resistor there, or was it just scratched on the... was it just an unpopulated one? Let's see if there's any of that unpopulated ones. Yeah, there's a one there, unpopulated. So it might have just been that was an unpopulated one, maybe. I thought I was onto something there. There is a line that just seems to come through. So I'm not sure on that. Actually, it does seem to go back from here as well, so... So I'm not sure on that one. So I'm just wondering if it's something to do with that current limiting chip here then. This thing here. Well, it looks like that gets its enable pin, if that's the enable. Yeah, so that goes to there. So that would only get enabled if it had power. That just doesn't make sense. I don't understand how you'd get the power from here to here when that needs to be enabled and it hasn't got any power to enable it. Right, I'll just zoom back out a sec. I mean, that mightn't even be the right chip that I've got the diagram for. My tweezers are a bit bent. But the problem seems that we're not getting the voltage to here from wherever it's supposed to come from. And it seems to come from there. I just wonder if somebody's plugged, let's say, the wrong adapter in like a USB-C high power one. And it's maybe fried this MOSFET or something. So I just thought I'd plug it in and connect the battery up and then try and measure some voltages on here. And I've just noticed I've got 5 volts there now on this pin. So the wall adapter pin is this one here. But when I measure that, I can just go on there. I've got nothing there. And that goes to that MOSFET here, which has got nothing on it. And that goes to this pin here, which has got 3.4 on. So I'm just wondering, it's not that MOSFET, but then again we should have 5 volts here. Where's this 5 volts go to? It just seems to disappear from here, and then I'm not sure where it goes after that. We've definitely got 5 volts there now. So if this is a P channel MOSFET, this pin's got to go low to switch the power from here to here. So it's high at the moment, so this MOSFET's switched off. That's right, isn't it? Just double check we've got. Yeah, so we've got voltage on the gate pin. And because this is a P channel MOSFET, it'll be switching a positive voltage from there to there. So because that's positive, this MOSFET's switched off at the moment, which is why we've got nothing on there. So there must be some kind of detection for when the power's plugged in. I'm just going to see if I can find on the data sheet of this chip if there's like some kind of detection pin that maybe it's not getting pulled up, that then tells it to switch over to the wall one. That's what it might be. Right, I'm just going to have another look at the data sheet. So I've just noticed something really odd here. On this side of the diode here, we've got 5 volts. But on this side, the voltage seems to be going down. $5 volts. I don't know why we've only got 3 volts here. Just going to see if I can see anything through the thermal camera here, but I'll just move the microscope out of the way a second. Let's just have a look with the thermal camera just to see. There doesn't appear to be anything getting hot. Oh, that's a bit odd. Why is the voltage dropping? I'm just going to unplug these a sec. I mean, that diode's measuring okay. I was just wondering whether it could be breaking down under load or something like that. Well, I've been having a look over the board again, and I think I've made a little bit more progress here. So, this is the USB connector just here, and this is the back of the board, and that's that suspect resistor, or where what appeared to be a resistor, but I wasn't 100%, but it looked like it burned out or something. So if I just measure voltage just on this pin here, we've got 5 volts, and this pin here is the charge input pin, or the wall input pin as it's called on the chip, and we haven't got any voltage there. So that switched from here to here with this MOSFET. If we measure the voltage here, we've got 4.9 volts. That means this MOSFET is switched off at the moment, but it seems to be controlled by this transistor here, which has got 5 volts going to it on this pin here, and it's controlled by the base of it here. So that seems to be controlled by this transistor, which then turns this transistor off, which stops sending 5 volts to the MOSFET, which then gets pulled up through a resistor here, and that enables the MOSFET, so then it sends 5 volts from that point here to this point here. I wonder what happens if I just bridge from here to here. I wonder if it starts charging. I'm just going to try that. Right, so it's this MOSFET here, and I've just got my meter in amps mode at the moment, so it's basically just connecting these 2 probes together through a 400 milliamp fuse. So if I short from here to here, we'll send 5 volts from this pin to this pin. And the current's gone up to 0.12 amps. 0.24 amps now, 0.34. And it looks like we've got the charge light on here. So it's definitely in this part of the circuit. Now I've just moved my probes off and the charge light's gone out. So I think it's that resistor missing, or broken. But obviously we don't know what value it should be. So what I might do is just try something like a 10K, and we'll see if that has any effect. And then if that doesn't work, we'll try maybe a 1K or something like that, or a 5K. So I think that's what I'm going to do. Right, I'll bring the microscope back in. Right, I've just tried a 10K across just from those 2 points, and it didn't do anything. But I've got a 2.2K resistor here now. Now you'll probably not be able to see this, but if I just touch those 2 points there, on my USB meter, it's just gone up to 0.16 amps, and it's just jumped up to 0.23 there. And the charge indicators came on. Now I know you can't see that. So what I'll do, I'll see if I can find a 2.2K surface mount resistor. We'll solder that in, and then we'll see if it works. Right, I shall go sort that out. So on my surface mount resistor kit, I actually haven't got a 2.2. I've only got a 1.8 or a 3K. So what I'm going to do, I'm going to try a 3K in it. So we'll see how that works. These resistors are actually slightly too big for this board. It's actually the smaller size I need, but it'll still work. Right, I'll find some flux. And where's my flux gone? My flux has fluxed off. It's on the floor. Right. Let's add a bit of flux first. Right, we'll try and solder that there. And hopefully it doesn't ping off everywhere. Just give that a bit of a clean up. Just grab a little cotton bud. Let's give that a wipe over. So I think somebody's plugged the wrong adapter into this. I think that's what's caused the fault. Right, let's power it up and we'll see if we get the charge light on. Let's move the microscope out of the way. Let's connect the battery back up. If we can get around the right way. Yes, I think that's working. Let's see. Yes, charge light. Excellent. Right, let's pop it back in the case and let's see if it all works. But we've definitely got the charge light on there now, and it's drawn. It's actually just jumped up now, 1.2 amps now. So yes, definitely charging. Excellent. Right, I'll get this popped back in the case. Plug a little speaker in. Let's just check where all the buttons are. And then we'll try and remember where all the screws went. Let's just get this display cable back in as well. I thought this would be a bit of a nightmare. Right, I think that's that done. Get the rest of these screws in. That one doesn't want to go in for some reason. Well, at least it wasn't a capacitor, it was a resistor this time. I was expecting it to be a blown IC or something. Right, let's just check all these buttons are working still. It's not Torx, is it? Sorry, it's not normal screwdriver, it's Torx, isn't it? So obviously I don't know what the original value of that resistor was. It looks like a 3K seems to make it work. I thought if I start off at the higher resistance first and then work my way down. Now have I lost a screw? Right, I'll just zoom out a fraction. And I'll just bring my little USB meter in shot so we can see the charging current. So 0.24. Yes, excellent. What a relief. I've been struggling to fix stuff all week. It's just been, I've needed order parts for different things, and things haven't just worked out very good this week so far for us, so I'm pleased to actually have a fix now. It's been a bit of a nightmare. Right, we'll let this charge up and then hopefully it all works. Right, I'll come back when it's charged. Well, it's been on charge for a while now and the current's dropped to 1.1 amps now, so we'll just give it a bit longer. Right, I think it's fully charged. The charge light's gone off. It is actually still drawing a little bit current, but I think that's because of the power management chip and that inside of this. Right, let's switch it on. Just unplug it from the charger. Yeah, because I think it actually runs from the charger as well. And it switches over to the battery when you unplug the charger. Right, let's just zoom down a bit. And how do you use this thing? Let's just have a quick look through. Looks like it's got quite a few games on it. Let's try Ghosts and Goblins, remember that one? I used to have the arcade board of this, and I got right away to the very last levels, but I still haven't actually managed to complete it. I think I was on the very last level. I think I played it all day when I was a kid and I still couldn't complete the thing, but never mind. Right, I think that's working fine. Excellent. Right then, If you enjoyed this video, please give it a thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comments section below. And as always, have a great day. Thanks for watching.